Hello, everyone. My name is Joris Peels, and this is 3D Printing News Unpeeled, courtesy of 3dprint.com, your daily 3D printing news roundup. And today we've got a couple of stories, and the first story it comes to us in the world of cycling. So there's been a lot of 3D printing cycling components. A lot of the innovation in 3D printed cycling components comes from small companies who are making seat stays and crankshafts and all sorts of components. We've also seen certain companies work on things like saddles and using carbon and other technologies. Um, but the main companies, the larger companies, have so far kind of been, well, they've kind of been involved with making one-off bikes or special bikes for Olympic teams and stuff like that. But this is about to change because Pinarello, which is a very large Italian, very prestigious Italian brand, is making a UCI-approved bike that is going to be commercially available for what is going to be, frankly, it's going to be a scary price point. We don't know what it is. This bike is made specifically for the Ineos Grenadiers, a pro cycling team, and even for cyclist Filippo Ganna. And the idea behind this bicycle is for Filippo Ganna to tackle the world hour record, which is essentially on a track, a special aero bike on a track, going as far as you can in an hour. And it's a record that's very prestigious, and a lot of people have been breaking it and trying to break it using their brawn and a lot of technology for many years, and they keep breaking it all the time as well. This bicycle is printed, and many of the components of it are printed using scalmalloy, which is a high-strength aluminum promoted by AP Works and other players. It prints really fast on the machine and gives you really good properties. So it's a nice material for this bike. It's made, actually, is being printed by Metron. Metron is a UK-based business that's done a lot of bicycle components for Olympic athletes, handlebars, all sorts of really specialized components and frame components and stuff, and has a really long relationship working with Pinarello as well. So that part is in good hands. There's also some nice things that, like, there's tube and seat post components that are bio-inspired by parts of humpback whales. Now, there's one really very one kind of new way of thinking, really, that came out of this bicycle. Now, of course, one of the things they're trying to do is reduce weight to a certain extent because there's limits on that. But you're also just trying to reduce drag, right? And you're trying to optimize the power output. So one interesting kind of tidbit that Pinarello is teasing is they can customize the bike geometry to the rider, or they may be able to do so in the ultimate production version, which would be very exciting because then you can customize it to your power output. You might have long, no long legs, but you might input power at a completely different angle. Different geometry might be optimal for you than for me, for example. So this to me is a really exciting approach. Customized bike frames have been around for a very long time, of course, but to do it in a 3D printing way might add some more advantages. Now, another thing that Pinarello is doing is this component here. There's a couple of components that are done like this. Now, this is based on work at the University of Adelaide, where they're looking at parts of the bicycle where drag is being created. Now, it's kind of obvious, but a lot of drag comes from the cyclist, right? Actually moving in these airflows and interrupting these airflows. And the idea that these parts you can see here are these geometries are supposed to reduce drag. In certain areas, there's a drag reduction in that particular area of about 39%. Through dealing with these kind of optimized surfaces. So this could be a very new way of tackling, making bicycles more high speed. This could be something that could be more widely available if it works. The bike is Pinarello Bolide FHR3D. Based on what we're told that is going to be sold commercially. So that's good news. And probably very few people will be able to afford this thing. That's my guess. But we'll see. We'll see. The next news is that Amnovis is to use the 3D Systems DMP Flex 350 Dual 3D printer. This is great news for 3D Systems because Amnovis is a company started by ex-Layerwise employees. Layerwise was a metal 3D printing startup in Belgium, got an early lead. This is in the European context, Northern European context, for printing also medical devices and other industrial components. And this team was later acquired by 3D Systems, and is the basis for 3D Systems, one of the bases for the 3D Systems metal printing technology. The guys at Amnovis, what they started to do was, well, as a startup, they are essentially helping people to design and commercialize medical devices. So it's great that they are still loyal to the 3D Systems platform. But the better part of this, why this is a really good deal for 3D Systems, is because, well, these guys can bring in many more clients and many more businesses. If somebody goes to them, they commercialize a really exciting spinal fusion cage. This could lead to much additional printers being ordered either by Amnovis or by another contract manufacturer or by that startup, for example. So I think it's a really crucial key customer to have. This could be a real boon to the 3D system, especially in a European context where EOS, AOS in Europe is very, very strong, of course, in the metal and polymer. So to have these guys use their ISO 13485 certification, build up medical knowledge to commercialize these devices on a DMP Flex Dual, that's a great thing, I think, for them. Another great thing is Creatio, which is kind of the production validation center for advanced therapies of the University of Barcelona. And they're kind of a cutting edge research, kind of implementation kind of part of the university. And they have recently bought a NGVC by Poietis. Poietis is a bioprinting startup that I like them because of the way they're strategically approaching this problem. I like them because of the way they partner with people, and they're working together with people on chronic wounds. They're working together on foot ulcers and ulcer therapies. And they're also putting together a kind of complete manufacturing package, if you will, that uses laser-assisted kind of microvalve extrusion technology kind of thing that has a really high cell viability. And I just love Poietis' vision. Now they're talking about putting a bioprinter in every hospital. And that's the kind of thing I think that will get a lot of people excited in this technology. And the idea of imagining that bioprinting could have some applications in those hospitals. Like, we don't have to, print maybe fully fledged hearts in the next couple of years, but we could maybe print some proto skin type of stuff for burn victims, for example, like that. So that kind of vision is really going to sustain investor interest. And I just think Poietis is, to me, the company to watch in terms of the way they pursue the bioprinting business, the way they put out their vision and are scrambling for cash now to sustain this vision into the next couple of decades. And so it's a great move by them. The printer has a Staubli TX240 SteriClean robot inside of it to do a lot of conveyancing. It's GMP compliant, and the guys at Creatio are also working in a GMP compliant environment. So they're saying, look, we work at the same GMP or CG or similar CGMP standard, and we work at like you want to work when you want to actually commercialize these devices later on. And this could be a real demo area. And imagine, of course, what this means, of course, for this university to be able to show off this really expensive printer, by the way. And to be able to do that development in Spain and to show people in Spain, to show them around, and they're going to show this system to all their medical device and medical customers that are thinking of doing this. So I think that's a great move for both of these guys. And we'll see the future of this. I think there could be a lot of work in bioprinting. I mean, I think the far off bioprinting future is going to take decades, according to the people that work in that area. Vascularization is still something that no one has really solved, which is a huge problem. But I really believe in regenerative medicine and tissue engineering kind of applications that could have really near-term advantages in cellular areas that are much more easier to do. So that's nice. We have seen today the launch of the B3300, which is a syringe-based system for flexible electronics. It's been launched by Nano 3D Print. It is a dual syringe with independent movement and lifting movement. By the syringes. Now, for this kind of printer, you can print, for example, it's like a syringe-based system using really inexpensive syringes that are replaceable, which is great. And you could do UV curable photopolymers. You could do things like silicone. You could do latex kind of stuff. And you can also do silver, gold, other kind of electronic conductive type materials. So, and it's going to cost about $6,000. So this is, I think, it's really an affordable thing. They're not going for the super high-end universities where there's only 5 in the world that can buy it, like a lift system or something like that. These guys are going for a lot of universities and a lot of research labs. And the price of $6,000 to me is a really great price for something. If it does what it says on the tin, it's a really great price that offers you a lot of experimentation. They've got a glass print bed and a video inspection system to check out the deposition and to adjust that. And yeah, the idea really is that you can mix and match a lot of ingredients here. You can make like really wearable kind of things. You can make like a silicone strap for something, and then make a sensor out of some conductive traces, and make that kind of a thing. The syringe can be replaced like really quickly, and they can do 100, 500 micron in one pass, and a minimum trace width is 0.2 millimeter. And I really like this as in a way of democratizing multi-material printing and democratizing kind of materials research that could come up with like soft robotics and other devices that can really be important in the future. Now, they are not the only ones doing this, because there's another company, and this is a Canadian company. A Nano 3D print, by the way, is American. And that Canadian company is called Voltera, and Voltera has reached the Nova. And Voltera started with a rigid PCB printer a couple of years ago, I think. And now they've made another printer, also for flexible electronics, also with a price point around $6K, so $6,000, and also kind of aimed at this conformal, stretchy electronics kind of market. So they have a pressure feedback system, which you can see in front of you, and also another integrated vision system to align the substrate and the print head. And they say that the system is a closed loop pressure feedback system, which could give them good results. And again, this is the kind of stuff that they're doing the same thing to make conductive materials, stretchy materials, skin safe materials available. And it's remarkable to me that we are seeing two of these systems be released on the same day. Voltera has some great examples here. This appears to be kind of a silicone, some conductive trace stuff embedded in it, which you could see, for kind of smart clothing kind of stuff, or some kind of wearable monitor type of a thing. That would seem to be a very exciting kind of a thing, or some kind of sensor for every time you turn around at night or whatever. And then this is another great example that they've made. This showing us, again, flexible electronics and stuff like that doesn't really make sense for a lot of stuff, but for something like this, like a prosthetic hand that moves and opens and closes all the time, that's there is really ideally suited. And it's also suited for all this future stuff that we don't really understand and we don't really know yet. So yeah, very exciting thing. I think there's multi-material approaches where we're using lots of materials in combination could be very exciting. And also, if we think about printing batteries, actuators, all that kind of thing, and at the same time, think about direct write in and of itself, just as a technology and how much research is going into there. So this could be a very exciting area for a lot of people to exploit. My name is Joris.